Health AI gives people a bad choice. Upload your medical records to the cloud to get help, or keep them private and stay stuck. 300 million people worldwide have their health records locked in siloed systems. So when a lab result comes back abnormal, most patients don't know what to do next. They Google, they panic, they wait. Hi, my name is Carl, and I'm building on Health Passport with a new feature that routes care called Care Router by Somach Incorporated. And we help you with this problem by doing two things. Your data stays on your device, and the agent acts in the cloud. For this Google challenge, specifically the optimization track, we took our working agent, Health Passport, and made it reliable enough to put in front of a patient. So, this is the local vault. We've got 10 files covering labs, medications, allergies, conditions, family history, all on device. Note that this is the original Markdown-based on-device file directory. This is just the backend visualized for this demo. So, the vault is editable. A caregiver can update medications, for example. This is what on-device means in practice. Here, the user owns the data, not the server. So, when I ask for a specialist here, you can see this happening live. The device strips every identifier first. Only an anonymized clinical intent reaches the cloud. As again, the agent calls search providers against MongoDB. You can see this here. It checks drug interaction against the current medication list, and then returns real matches from the database with the clinical reason for each and a draft referral. Identity is reattached on device, never in the cloud. Although for this demo, I used our cloud APIs for speed. That's all of our tool calls. And now to show you how it works, every tool returns a structured envelope with OK, search mode, and a degraded flag, meaning a failed text search can never look clean because the agent has to disclose it. To reinforce that, the system instruction forces even every provider name and rating to come from a tool result. So if the search returns nothing, the agent says so. And the same agent can reach MongoDB natively through the model context protocol. MCP flag on, same data, native path. And here's the part that matters. The prototype demoed fine and failed quietly because it ran 2 different agent loops, so we weren't even testing what we shipped. A failed search silently fell back and looked clean. It could name a provider that didn't exist. So we measured it. 24 grounded scenarios care routing. 357. 24 grounded scenarios score routing. Grounding, safety refusals, PII handling, and completion. We unified everything on one ADK runner, forced every provider name to come from a tool result, and added explicit refusals. Routing accuracy as a result is 100%. Safety refusals went from 75 to 100%. Overall pass rate went from 58 to 83%. Grounding is at 75% because 7 hallucinated names left in the multi-specialty were used as edge cases. That's documented. And that's why we measure. The scoreboard is the next iteration's starting point. And if we direct our attentions here, the reliability is a regression gate that runs with no credentials. So it's checked on every change and not staged once for this video. For the business side of things, Somach Care Router is a product built on top of Health Passport, which won the Qualcomm and Nexa on-device Grand Champion. As you've seen earlier, it's also live in Google Play. We've raised $33,000 non-dilutive and the wedge is 63 million US family caregivers. A routing agent that gives wrong referrals can't be charged for in healthcare. Reliability is what makes it sellable. That was Care Router by Somach, built with Gemini, the agent development kit, and MongoDB over MCP. Your data stays local and actions happen in the cloud. Thank you.